Welcome. I'm David Stokes with Broadcom's Mainframe Software Division. Thank you for joining me today. In this brief session, I'm going to share some insights with you to help you decipher the arcane world of mainframe licensing. I've worked in the mainframe software industry for more than 20 years, helping to design and implement many of the mainframe software licensing models we use today at Broadcom. However, the scope of our discussion will be focused on larger mainframe licensing concepts within the ecosystem, not just Broadcom models. In this brief session, we will discuss how mainframe licensing models have evolved, how you can optimize for both consumption and cost, and some recommendations for improving your licensing outcomes. Since 1969, there have been only two basic licensing models available to customers for the mainframe: full capacity, and then in the 90s, sub-capacity licensing models were introduced. The best way to illustrate these models is to think about New York pizza, which is without question the most superior of all pizza types. The standard New York pizza is round and comes in a square box. It is almost always divided into 8 equally delicious slices. If a pizza parlor only offered pizza using a full capacity model, then whenever you went there, you would only be able to order a full pie, regardless of your appetite, never a single slice, regardless of the time of day. The full capacity model was simple. Fixed costs for an entire machine gives you financial predictability and certainty. Both the hardware and the software were licensed to the high water mark. This was the mainframe market for the first 30 years. As mainframes evolved, each generation of machine grew larger and more powerful than the previous, enabling customers to do more while consuming fewer compute resources. So around 1999, sub-capacity licensing for software was introduced. While you still purchased hardware for your peak utilization, you could license your software for less than the full capacity of a machine. This model provided more granularity at a lower price point, but it also introduced more overhead and complexity, as well as less financial certainty and predictability. Because sub-capacity licensing models introduced a new metric with a new variable, the rolling 4-hour average. And something new impacted your costs now: time. When you want to run your workloads could impact your software licensing costs. This is where things got a bit more complicated for both customers and software vendors. Up until now, contracts were full capacity agreements based on MIPS. Very simple. Millions of instructions per second. Add up the number of MIPS, that's your capacity. That's what you paid for. But now, with sub-capacity licensing, we are no longer simply measuring the capacity of a machine. We are measuring usage over time. To explain, I want to visit our pizza parlor again. Imagine if our pizza parlor charged a different price based on demand throughout the day. Naturally, the price of pizza would be the lowest in the morning when demand was the weakest, then rise throughout the day when people got hungry at lunch and dinner. When there were major sporting events like NCAA March Madness or the Super Bowl or a World Cup, that would create additional surges in demand that would unexpectedly impact the price, sometimes resulting in slices costing 2 or 3 times as much because of when you were ordering your pizza. So if you wanted to lower costs, you would need to eat at off-peak times, even though you were hungry now. The mainframe works more or less the same way under the rolling 4-hour average. When it was first introduced, the rolling 4-hour average made sense for many customers. Even though software licensing had been changing, hardware licensing did not. You still had to buy hardware to your peak utilization. At the time it was introduced, most customers at a minimum were about 80% utilized of their Z hardware. So the rolling 4-hour average allowed you to manage unused hardware capacity by helping you to align your software licensing with less than the full capacity of the machine. While this worked for many years, in recent times, it has led to some unnatural acts. Many customers began to configure their systems to avoid peak times, slowing down workloads to manage software licensing costs rather than configuring them for optimal response times and service levels. They did this by executing batch workloads during off hours when their online systems were down, kind of like taking an Uber during off hours to avoid surge pricing. or throttling their development and test systems, or throttling access to their development and test systems, putting development workloads into the valleys that you see on the left. Also, software and hardware capping schemes, and the implementation of tools to manage capping, all of which limits the amount of resources available to a workload, just so you could avoid licensing charges. For 20 years, the rolling average, 4-hour average worked, but things began to change. Larger spikes and increasing variability in customer workloads. The mainframe was no longer in isolation. Transaction volumes on the mainframe have been increased significantly over the last 20 years. $0 transactions, read-only transactions, the kind of workloads where you look up an account balance, check the status of a delivery, a billing record for a text message or a phone call, are the cost of doing business today. You have to provide these kinds of services to do business. Modern mainframe workloads are subject to many more unpredictable surges as a result. For example, during the COVID pandemic, many countries provided stimulus payments to their citizens. These payments had some unexpected consequences for many financial institutions. As the date approached for each Treasury authority to issue payments, many retail banks were seeing massive surges in activities, driving their CPUs to 100% or even greater levels of utilization. What caused this? Everyone refreshing their account balances to see if government payments hit their accounts. Whether it was a consumer shaking her phone to refresh account balances on a mobile app, or someone hitting refresh on a website, these actions drove hundreds and sometimes thousands of mainframe transactions in the background each time. Other factors include declining utilization. Through all of these licensing models, metrics, and changes, hardware was still being purchased for peak usage. Regardless of duration, machines got bigger to handle these increasing peaks in customer workloads, so utilization has fallen significantly. And finally, the DevOps transformation. This transformation shifted left and required more robust test systems for customers who wanted to test early and often in their development process, required more robust systems. Testing earlier in the software development process creates demand for both more robust test and development systems, making it much harder to fit those kinds of workloads in the valleys between the peaks. So while the rolling 4-hour average was a good start, providing customers with a way to manage unused capacity is not kept up with the market. So what should you do? How can you optimize for both consumption and cost? First, remove time as a constraint. With time-bound metrics like the rolling 4-hour average, you cannot predict how much it will cost until when you need to run your work. Organizations need visibility and predictability and transparency in their licensing models. Follow our lead, explore consumption licensing models like Broadcom's Mainframe Consumption Licensing Program. Do it with other vendors too. We also suggest eliminate all capping. We did not spend a lot of time on this, but capping workloads restricts the amount of hardware resources that are available to a particular workload under certain conditions. It limits the value of your hardware and software investments. It also eliminates the need for software and people to move workloads around. And finally, align your hardware and software models to get better performance and cost. More headroom yields better performance. By decoupling capacity-oriented agreements to maximize this benefit. These kinds of changes should enable you to have workloads that run like the left, but gives you the predictability of charging like the right. Thank you for taking the time to join me today for these mainframe insights.